Going.
Math! Welcome to math. We're doing math. I'm your host, Professor Math. Not my real name. Working on three things. Area of a rectangle, of a triangle, and of a parallelogram. Okay? These are like building blocks for finding the area of different kind of shapes. It's really important to know these. First of all, what am I talking about when I'm looking for the area of something? When I say area, what am I looking for? Mateo?
The inside of it.
The inside of something. Okay? So for example, can you see this? Am I okay on the screen
Yep.
still? All right. A rectangle like that, okay? Area is finding the inside of that rectangle. So if this is a 5 by 6 rectangle, all I'm looking to do, okay, this just means I literally have 5 rows, and in each row, there's 6 of something. So if I were able to split that rectangle up equally, I would end up with 5 rows with 6 in each row. That's all that means, okay? Could be in centimeters, meters, feet, inches, whatever, doesn't even matter, okay? Or nothing like this. It's just no unit, just 5 times 6, okay? All I'm looking for is the inside of that. So I could quite literally, for a shape like that, count 6 5 times. Just count the inside, all right? The reason why we use formulas for area is to save all that hard work, to make it faster. So instead of counting up the area in there, I use a formula like this. 5 times 6, okay? Or 5 groups of 6. That also means groups of, okay? So the formula for a rectangle is the length times the width, okay? And it doesn't matter what you call length and what you call width. In some cases, if your shape's kind of like this, right? Well, obviously, length probably is the longer one. Doesn't really matter, as long as you stick with the right one each time. So in this case, length, we'll say length is 6 times width is 5, okay? So length is up here, width is up there. And it's times those, right? I can count 6 5 times. I can count 5 6 times, even easier. I can use a calculator. Whatever you want to do to solve that question. So I know that 6 times 5 is 30, okay? I'll write 30, I know that in my head, automatically, okay? So my area, my rectangle is 30. It's just length times width, okay? Now, for a triangle, it's really funky, okay? Because a triangle, all right, if I take a triangle like this, okay, and I put a second triangle like this, okay, I can see that first triangle is just half of a square, right? Half of a rectangle. Even a longer triangle like this, if I put the top part on there like that, okay, it's still a rectangle. So the cool formula for finding a triangle, we call it base times height, and then divide all that by 2, okay? My base is the same thing as like my length here, right? So if this is 12, okay, my height here would be 12, or sorry, my base here is 12, and the height is just like the highest point, all right? And either you measure that or you're given that information and you plug that into the formula. And that's just the other side of that rectangle. So in this case, my highest point is right here, right? That's my side there. If I were to complete that rectangle, that's the same side as like width is here. So if this is like 7, okay? My formula for a triangle then is base times height divided by 2. So base is 12 times 7. And this little like fraction guy there, right? That's a half fraction, right? Like 1/2 is a half. That just means take the answer here and split it in half. Okay? So I know that 10 times 7 is 70. I know that 2 times 7 is 14. Just broke apart that 12. I know that 7 plus 1 is 8. 4 plus nothing is 4. So 84. So I have 84, right? But divided in 2, because 84 is the whole rectangle. It's a triangle, so I cut that in 2. So 84 divided by 2, well, half of 8 is 4. Half of 4 is 2. So my answer for just the triangle is an area of 42. Okay? So rectangle cut in 2. Okay? Last one, okay, is our parallelogram. All right? A parallelogram is a crazy shape. Looks like this. It has 4 parallel lines, right? These two are parallel. These two are parallel. All right? The trick with this is I can actually make it into a rectangle. How, KJ? Good question. I cut this part off here. You'll notice I put it over here. It actually looks like this. Okay? And then wowie zowie, look at that. It's a rectangle. Kind of erase that line there. I've moved that. It's a rectangle. Sweet! All right? So now I can use the same formula I use to solve for a rectangle. Okay? When you see a parallelogram in math, right, you'll often see like this. You'll be given this value here usually, and you'll see a little line like this. Okay? That's like the pretending that it's cut off there and moved. Okay? And it'll give you a value there. That's your height. Right? Or, when you move that over, this is your length, and that's your width. Right? So the formula for parallelogram, base times height, all it means is like I'm just cutting that off, putting it here, making a rectangle. I just call it height because it's not quite like the width or length unless I actually move it over and cut it off, right? So in this case, my base is 24, so 24 times 8 is my height, right? Remember, to move that over there, make a rectangle, it's just like length times width, almost the same thing, okay? I know that 20 times 8, well, 2 times 8 is 16, so 20 times 8 is 160, and then 4 times 8, I even know 4 times 8, do 2 times 8, then double that. Curtis?
32.
32. So I'll add that, 2, 9, 1. My answer is 192 for my area for the parallelogram. Okay? So that's it. Square or rectangle. Triangle is just half of a rectangle. Parallelogram, we're just cutting that up and making it into a rectangle using our height number and our base number. Right? And just calling it base times height. It's only length times width of like a rearranged rectangle. Okay? Awesome. Thank you for watching. Like, subscribe, and feed your fish.
Don't. Please.